Alright, now I'm going to try and explain the conservation of momentum. Now, the conservation of momentum is a principle that states that the initial momentum of a system should be equal to the final momentum of a system if there are no external forces at play. So if we have a collision between two objects, say two blocks, block 1 and block 2, let's say these each weigh the same, 3 kilograms, and let's say that initially the velocity of block 1, v1 initial, is equal to 5 meters per second. And block 2 is stationary. v2 initial is equal to 0 meters per second. Eventually, block 1 will collide with block 2. So at that point, all of the energy from block 1 will be transferred into block 2. And then after the collision, block 1 will be stationary, and block 2 will be over here somewhere, moving away. So block 1, initially it's moving towards block 2, they collide, block 2 is moving away. So now the velocity 1 final will be equal to 0, and if we want to calculate the velocity 2 final, we can use the principle of the conservation of momentum. So we know that the initial momentum of the whole system will be the momentum of block 1 plus the momentum of block 2. So the momentum of block 1, which is just mass times velocity, so we'll say m1 times v1 initial plus m2 times v2 initial is equal to the initial momentum of the system. So m1 is 3, v1 initial is 5, plus m2 is also 3, times 0, v2 initial. We will have 3 times 5 plus 3 times 0. 3 times 0 is just 0, so 15. So the initial momentum of the system is 15 kilogram meters per second. Kilogram meters per second. And we know that the initial momentum should be equal to the final momentum. So if we want to calculate the speed of block 2 after the collision, we can use this principle. We'll say that m1 times v1 final, which is now 0, v1 final plus m2 times v2 final, should be equal to the initial momentum, which is 15. We just calculate. So now we can back into the number of v2 final because we have all the other 3 variables. So we'll have 3 kilograms times v1 final, 0, plus 3 kilograms for block 2, times our variable we're looking for, v2 final, should all be equal to 15. So the momentum of block 2 at this point is going to be 0, 3 times 0, plus 3 times the velocity 2 final, which is what we're looking for. So we can divide out the 3 on both sides, and we will have a momentum, or we will have a velocity v2 final is equal to 5 meters per second, right here, which is the same as the initial velocity of block 1. So when both objects have the same weight after the collision, the first object will transfer all of its energy into block 2, and equal and opposite reaction, block 2 will transfer energy into block 1, slowing it down. And after the collision, block 1 will be stationary and block 2 will be moving away with the same velocity that block 1 had initially. And we can actually see this in action. So I built this little contraption here, a little pendulum, Newton's cradle. If we have these two objects, we'll say ball 1 and ball 2, they weigh the same. So if I take ball 1 and hold it back at this angle, once I let go, I would expect the ball to accelerate down, collide with ball 2, at which point ball 2 will transfer its energy into ball 1, slowing it down, and vice versa, ball 1 will accelerate ball 2 and swing it out this way. So ball 1 will stay stationary here, and ball 2 will swing out this way. And because our final velocity is equal to our initial velocity, I would expect this ball to swing to the same angle that I hold this initial ball at. But in a perfect world, that's what would happen. But we might have some frictional forces and air resistance slowing things down. So this ball should be roughly the same angle away once I let go. Let's see. That looks about right.